So today, Common Core, I've got that written down. Let me go ahead and refine that. My Common Core is, yes, here it is. We'll put that up there. So my Common Core is going to be functions, and it is interpreting functions IF, and it's write functions. I'm going to write functions by an expression in a different and different equivalent forms. All right. And I'm going to try and do the Common Core every day. It's just my job, and if it's blah 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 to you, that's okay, but we are required to do the Common Core. So until President Trump changes it, we've got the Common Core, okay? So now, in each example, state the property. So we just read about our properties. We had the additive, identity, multiplicative identity, boy, I can't talk today, additive inverse, multiplicative inverse, commutative property, associative property, and distributive property. So what we want to do is just take a look at our notes and just decide which property is being illustrated. So I look at A, and I kind of notice this little thing here. And that's got to be the distributive property. You guys agree? Okay. B, looks like the order changed, right? You guys remember which one that was? Commutative. Yeah, it's commutative. If the order changes, it's commutative, all right? C. It's the grouping that changed, didn't it? Do you see how the grouping changed? So instead of multiplying, 3 times 5, I'll do the 2 times 3 first. So it's going to be the associative property. Now let me back up to B, commutative property of addition. Okay, because it is of addition. And that makes C the associative property of multiplication, right? And I'll abbreviate mult, right? C, 8 times 1 equals 8. It kept its identity, didn't it? Kept its identity. So it's going to be the multiplicative, fancy word, multiplicative identity. E, kind of adding it to its opposite, right? 8, negative 8. But in math, the word inverse means opposite. So it's my additive inverse. Additive inverse. Mia, can you guys see okay back there? Okay. And then finally F, 2/3 times 3 2's makes 1. So it's a multiplicative inverse. Multiplicative inverse, okay? All right, example 2. 2 questions. First of all, the additive inverse, and then we'll do the multiplicative inverse, okay? So 2 questions. So to do the additive inverse, I've got a negative 1/5 plus what would make the whole thing equal to 0? 1/5, that's it. It's that easy. It's really that easy. So 1/5 is the additive inverse. When you add it to the negative 1/5, you get 0. The multiplicative inverse, if I have a negative 1/5 times something is supposed to equal 1, right? Yeah, Austin?
5 over 1.
It's going to be negative 5 over 1. I'm sure you said negative, didn't you? Yeah, negative 5 over 1, because you need the negative times the negative, right, to make it a positive. Nice job. Okay, does that make sense? You've got to multiply it times its reciprocal to make it equal to 1, okay? Now, I want to see a show of hands. And it's okay if no hands go up. It happens to me a lot. Have you ever simplified square roots? Good. Good. All right. I'm glad to see it. At least half of us, right? So what happens in example 3, first of all, let me show you a calculator, okay? So if we take the square root of 24, it's not a perfect square root at all. So if we just take, for instance, square root of 24, we get a decimal, okay? And the problem with the decimal is this is an irrational number, irrational. So it's like pi, and it just keeps going on and on. So this is technically, right? This is technically not the right answer. I mean, 4.898979486 is not the answer because it goes on and on and on and on and on. It never ends. So what we need to do then is find another method so we can have an exact answer. So what I want to do is reduce it. So when I want to reduce it, I'm looking for things called perfect squares. I'm putting my little column here, perfect squares. Well, 1 is a perfect square. 4 is a perfect square. 9 is a perfect square. What's the next one? 16 is a perfect square. You catch on to what I'm doing? These are the numbers that have a square root. What's the next one? 25. Good job, Alyssa, is a perfect square. And then? 36. Yep. 49. 64. 81. 100. Thanks, Angel. Let's get a couple more, huh? 121, right? 144. Anybody know the next one?
169.
169. Very good. Anybody know the next one? It's 196. Might be 196. So it'll be 14 squared, right? 196. Yeah, it is 196. And then we'll go all the way, the last one will go 225, because we know that these numbers have answers. They have nice answers. I mean, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, right? The square root of 36 is 6, the square root of 49 is 7, the square root of 64 is 8, the square root of 81 is 9, the square root of 100 is 10, square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. Square root of 169 is 14. Square root of 225 is 15. Anything beyond that, it'd be difficult for you guys to memorize, right? I mean, that'd be too big. But those are the ones we want to look at. Anything bigger than that, we're probably going to need a calculator, right? Okay, those are perfect squares. So if we go back to example 3. There are many ways to teach this. I'm going to teach it the way that works, I believe, for you. I've been doing this a long time. If you've learned it another way, use your other way, but this is the way I do it. Okay, listen. I need multiples, 2 numbers. What times what makes 24, but I absolutely have to have one of these numbers. That makes sense, Austin?
4 and 6.
Right? Well, yep, 4 and 6. So I'm going to rewrite this as square root of 4, square root of 6. Now, think about this. If I use 3 and 8, it's not one of these numbers, is it? 3 and 8 won't work. You need to find a set. Now, don't ever use 1. 1's kind of ridiculous. Doesn't get you anywhere, right? Using 1 doesn't get you anywhere. So if I use 4 and 6, one of these two numbers, the 4 has a square root, right? So you take the square root of 4, and you get 2 square roots of 6. That's all I want you to do. Okay? What we've done is we've reduced it. We've allowed ourselves to get a whole number out of it that we could then maybe divide out later, which might help us in a simplification problem. Okay, that's why we do it, because later on we might need to divide out that too. Okay, how about example 4? Well, the 3 is a regular 3. Don't mess with it, just leave it. The 3 is a regular 3. Okay, write it down. It is not inside the square root, it is a regular 3. But no, what about 18? Go ahead, Austin.
9 and 8.
Everybody agree? And Austin's saying it the way I like to write it. I like to write the perfect square first. It just is easier to work with, okay? So then the square root of 9 is 3, right? So just this 3 is the first 3. Square root of 9 is 3. Square root of 2. And then I get 9 square roots of 2. Okay, thumbs up. You've done this before, right? You guys done this before? Good. Okay, return the page. Now, example 5. So really, example 5, since I'm not much of a typist, should be like 27 over the square root of 4. That's a better way to write, okay? So I'm going to rewrite it as the square root of 27 over the square root of 4. Now, the 4 is easy. Should we just take care of the 4 right now? The 4 is easy. Square root of 4 is just 2, right? Just take care of that. Square root of 4 is 2. Now, but what about the 27? That's not a very nice number. What about the 27? Somebody says, Austin, you're off. You're done for the day. Thank you, by the way. Thank you. But I'm cutting you off, okay? Well, what do you think? 9. Square root of 9?
Yeah.
Square root of 3. Everybody agree with that? Because 9 times 3. And 9 is one of our good numbers. It's a perfect square. Square root of 9 is, so we change that to a 3. 3 square root of 3 over 2, okay? Easy? Thanks, Austin. Sorry to cut you off. They will rely on you. Okay, example 6. So let's multiply. The 2 is a regular 2. Leave it, just leave it there, okay? But the square root of 6 times the square root of 3. You can multiply square roots together. You're going to get a square root of 18. Okay? And then I could probably break down 18. I think Austin told you how to break down 18 earlier. What are the multiples of 18? 9, 2. You guys agree? So the 2 is a regular 2. 18 becomes a 9 and a 2, right? The 2 is a regular 2. Leave it alone. The square root of 9 is a 3 times the square root of 2. 2 times 3 is 6. Square root of 2. Okay. Thumbs up? Yeah, Will, question.
Why can't you just add the square roots? These going to be square root of 9.
Great question. You know what? There's a little symbol here we never write. And what's the little symbol? It's a times sign, isn't it? When two things are right together, you got to multiply. But now look at example 2 or example 7. This one we are going to add. So it's like when you have.
You go up a little bit.
Yeah. Okay. So like, well, think about this. When you have like a 3x, we don't put a little times sign in there, but we know it's 3 times x, right? These are the same way. Even though there's no little symbol in here, if they're right next to each other, we got to multiply, okay? Good question. But now look at 7. 7 definitely is add, right? Now when you add, they must be the same. When you add, they must be the same root. If they're not the same root, you can't add them, all right? Okay, so when you add them, it's like saying this. I have 2 square roots of 3. Let me add to that 4 more square roots of 3. So in the end, I should have 6 square roots of 3. Now think about it. Not 9s. There are no square roots of 9. There's no 6s. It's square roots of 3. I've got 2 of them plus 4 of them makes 6 square roots of 3s. How many square roots of 3s do you have? Does that make sense? You've got a total of 6. Okay, now number 8 though is a little bit different because at first when I look at it I think, oh, I'm done. I can't add those, can I? But maybe if I break them down and reduce them, maybe I can. Because right now I can't subtract them. But let's try and break them down. Maybe we'll get some good numbers. So what about 18? Okay, you guys know we've done 18, right? 9 and 2, square root of 9, square root of 2, right? Which makes 2 times a 3, square root of 2. Am I going too fast? Okay. So I made the 18, 9, and 2. Took the square root of 9 is 3. 2 times 3 is 6. I get 6 square roots of 2. So I just changed this 2 square roots of 18 into a much better problem, okay? Now what about the 27? How about 9 and 3? Well, square root of 9, I can do that. Square root of 9 is a 3 times the square root of 3, right? 5 times 3 is 15. Now I did all that work to see if I could subtract them. I still cannot subtract them. They're not the same. They have to be the same to add or subtract, okay? You can multiply anything. You can multiply, but if you add or subtract, they must be different, okay? Now, example 9. Well, looks to me like I can't subtract them. But how about 150? Go ahead, Austin. What do you see?
25 and 6.
25 and 6. And if you have a hard time, think about money, okay? Think about money. Okay, think about quarters. If you had $1.50 in quarters, you'd have 6 quarters. Does that make sense? So I know that 25 times 6 is 150. Now, if you're not sure, you can use your calculator. Okay, well, shoot, what is 6 times, 25? Hey, what do you know? 150, right? It does work. It does, okay? So then, square root of 25 is a 5. And now bring down. Now you can't reduce 6. Think about it. 2 and 3, that's not going to help. Remember, we want all these special numbers here. So you're going to have just a minus a 3 squared, it's a 6. But that's okay. That's okay because I can do more with this, right? I can subtract them, right? So if I go 5 squared root of 6 minus 3 squared root of 6, I'm going to get a 2 square roots of 6, okay? Pretty easy? All right, here's what I want us to do. I'd like